Okay, we continue the second block. We have a little change in this program, but still a very exciting lecture, a keynote. Very happy to have Grega Milcinski with us here from Slovenia. He's a co-founder of the Synergize, and I think many of you, if you don't know Grega directly, you probably touch the Sentinel Hub. So that's I think your flagship product, right? And I used it. I actually paid a service back in let me see something like 2019, I think. I used it. I said, oh my God, this is so easy now. I can just get this mosaics. I can get the data. So I'm also your customer, Grega. But very happy to have you here, and please let us know about the CDSE and OpenGeoHub monitor collaboration and scale. Thank you.
So hi everyone. So I'm wearing two hats today. One is on behalf of ESA and DigiDefis presenting the CDSE, but Synergize is also part of the OpenGeoHub monitor project, so I'm kind of both worlds. So what I want to talk about is why we're actually here, what we want to do with Earth observation, and how CDSE and OpenGeoHub monitor can actually contribute to that. Now, what do we want to do? Why we are investing all this time and money into the satellites and observation and so on? I feel that the reason is that there is very few sources of information that are as objective and as systematic as the satellite imagery. I mean, there are probably a handful of similar things that give you the insights of our planet on a, I don't know, daily, weekly, monthly basis for the whole planet, like in a harmonized way, and on and on and on for years to come. There's really, I mean, there's such a wealth of information, and we need to do something with it because it's so valuable. Now, what do we do with it? I feel that this should have kind of an impact to our daily lives. Like every day we do some decision, the satellite imagery should be part of it. And similarly as with the weather, like there is the weather monitoring and we take a look at the results. We don't care whether there is a weather monitoring and there are satellites or not, we just use the results. And I mean, with how this could work with the remote sensing, kind of, I feel me walking into a Zara store and trying to buy a t-shirt, and I'm looking at, I would like to know, I don't know, how much of a climate impact that specific t-shirt, like making of that t-shirt has. And I mean, with the satellite imagery, we could get this information pretty well, but obviously there is quite a long link between that t-shirt and satellite imagery, and therefore this information is not available. So in practice, what we are using satellite data for is unfortunately mostly just looking at all the damage that we have done, right, and that we continue doing to our planet. Like after the fact when it happens, I mean, they are strong, impactful visualizations, but they don't really change our patterns. And I think that's a problem. And it doesn't need to be that. And I know that because there are, again, a few cases which demonstrate that satellite imagery can change patterns. One of them is area monitoring service in the common agriculture policy. So there, for a few years now, we in the European Union are operating the system that is based on regularly updated satellite data, Sentinel mostly, obviously, to basically control the distribution of tens of billions of euros of subsidies that go to farmers every year. And like there, the data are really deeply ingrained in the process, and it really, really works. I mean, works to the level that some farmers don't get paid for it, and it stands in the court. So it can be done. Now, the path to get this to the level of in common agricultural policy was quite long. And I feel, I mean, I want to just elaborate a bit so that we see how we can do this with the rest of the things. First of all, there was already a long-standing policy in common agricultural policy which was important, which had like a significant financial impact. So basically it motivated people to do things accordingly. And there was a big demand to actually make things right, simply because there are literally 50 billions of euros every year distributed with that. So, I mean, you can spare some if you introduce some controls. Second of all, this policy had a geospatial domain quite strongly ingrained for, I think, since 90s or so. I mean, it started with people realizing that some countries, and I'll not mention that one of these countries is Italy, have like subsidies, the agriculture area covering more than the area of the country, right? They really were very efficient in making the crops even in the sea. So they introduced the geospatial systems to kind of prevent this kind of fraud, and it helped a lot. And even like kind of 10 years ago, they already started to use a bit the satellite imagery, doing some small, I don't know, a few percentage of farms every year they validated with the satellite imagery. So they were familiar with the process. And then Sentinels came along and they said, this is perfect because we can get weekly data with a resolution sufficient to monitor the vegetation. This fits perfectly to the Common Agricultural Policy. Let's use it. So there was a policy, there were some geospatial understanding, and there were the data. But it took still 5 years or so, starting with DG Agri asking ESA to start a research in this field. And they did, as ESA typically does. And they introduced scientists, and scientists developed the algorithms to do, I don't know, crop classification and so on for this specific purpose. And it worked. I mean, they demonstrated that it can work. And then the industry came and basically built on top of this knowledge. They made it good enough that it can stand in court. They incorporated it in the business processes. With the business rules, all this tedious accounting stuff that nobody of you probably wants to work with, but it's important if we want to make an impact, right? And all these components needed to work like in tandem, industry providing feedback to ESA, to the DG Agri, how the policy should be changing, researchers likewise, and it kind of worked. In a few years, this came to a conclusion in terms of that it became a law, and now for several years this is a law, and every member state is using this, and they're using it pretty well. Some obviously better than others, but it is impacting daily life of, in this case, farmers, and they're pushing them to be more compliant with the good agricultural practices. Now, in this process, we kind of we Synergize was part of just this, the whole research and so on. So I'm talking in the first term. We developed like kind of a different segments of how to get to that. First one, obviously data. Sentinel, Sentinel-1, Sentinel-2, some commercial data like Landscope and so on, but mostly Sentinel. As Tom mentioned, the data are typically too noisy to be worked directly with it. So there was a need to create an analysis-ready data stream from this data. And then what we did is that we took the ARD and we took the area of interest, which in this case are polygons representing parcels, and we created signals. Basically, very simply, statistical analysis of the time series of the pixels over that area of interest. The reason why we did that is that we reduced the complexity of data by 2 orders of magnitude, which also sped up the further work while still keeping the accuracy. Now, from signals, we created insights. I learned today a new term, PRD, policy ready data. Policy relevant data, sorry. I would say, I mean, we call this markers, but I would say this is the same thing, right? I mean, markers to me are like in this case, in the case of Common Agricultural Policy, markers for land cover, crop classification, the date of the harvest, the date of when the bare soil was visible, whether the greening happened over that period of time, whether the grassland was converted into something. So policy, because this was all related to Common Agricultural Policy, and the policy provided some rules of what can and should be done. And we basically extracted everything that could be extracted from satellite imagery related to the policy and created this PRDs. And I think the markers in this case are important because they fit in Excel spreadsheet, right? I mean, once you extract information to the level that it fits in Excel spreadsheet, then it can also fit in business rules, decision trees, all these things that again can be then interpreted in law and can be understood by a judge in the court, which is maybe assessing a case that somebody didn't get the subsidy. So this is important if we really want to make use of the data. And then there is this last step where we want to actually incorporate all of this into applications which can be used by the operators in the ministry, which are not familiar with neither the satellite data nor all these algorithms. They just look at the pictures, look at the markers, in this case PRDs, and make some decisions on top. These are the steps that are needed to get data, Earth observation data, into a real life impact. So again, converting, extracting information to the level that fits in Excel or to the level that is understood by the policymakers, which are typically not experts. We need really this simplification, and we need it on as many fields as possible. How the CDSE can help with that? In short, I would argue that CDSE basically solves the problem of the data access, and basic data processing. These things are checked. We don't need to put more effort into making it better. It can be better, but it's good enough there, right? We can take that and work on top of it. And it should be used by researchers, policymakers, and companies to actually to do the further added value steps, extract information, to build the PRDs, build applications, and so on and so on. I'm not going into details because I hope that many of you or most of you already are familiar with CDSE. Just to mention that it's really large, like almost 100 petabytes of data today. It's there for a long term, and it's an open ecosystem. So you can take the bits and pieces that you need and integrate them in your process. The data Sentinels is the core of it, but it's not just Sentinel, right? We go one step further. We try to create the ARDs there as well. In this case, they are quarterly cloudless mosaics of Sentinel-2, updated regularly, going back to the beginning of the mission, the RGB and near-infrared bands globally, right? So again, there is no rocket science there, but it's done at one place, one time, so that everyone can use it rather than rebuild it. Similarly, we do the monthly Sentinel-1 mosaics, again, globally. There we go one step further toward ARD, creating the radiometric terrain correction in line with the CEOS standards. So all the, again, complex steps so that you can just come, take, and use it for the whatever research or the process you need. There are VHR coverages. Every 3 years, the European Commission orders the VHR coverage of the EA39 area, and this is also available in CDSE, RGB, and near-infrared, with, unfortunately, some specifics on the licenses, because, as it was told previously, the commercial providers typically are not too happy with providing the data as openly as one would have hoped for, but it's still useful and it can be used, right? This is important. Yeah, there are some restrictions, but it can be used. Then this, I think, is a pretty nice step that we've done like a few months ago. We added the Copernicus land monitoring services, which basically goes towards the PRD. I don't think that CLMS is PRD. It's the derived data, signals, maybe you would say. Some parameters like their land cover forestry monitoring are almost like that. Anyway, again, available globally or European scale resolutions of 10 meters to a couple of kilometers. Some parameters are hourly, some are annual. Like more than 80 of these, you can come, pick, use it immediately, right? There is no need to wait, no need to order, you just use it. And there are more coming. So there is, oh, that's a mistake. So Landsat is available from 2020 onwards, not 2000. That's an important distinction. Again, updated regularly, collection 1. This will be available like, I don't know, in a few weeks, literally. Moody's is coming also soon in a few weeks to add value to whoever wants to use it. One other important tool that is built on CDSE is the Rapid Response Desk, where either the security services of European Union or researchers can get access to new data, like a new VHR or SAR data that are either tasked or from the archive. For a specific purpose, typically every Horizon project that is related to Copernicus comes with the quota which you can use to get access to high resolution data. And again, it's built on CDSE. You can use it. You can use all the services with the data coming from numerous the commercial data providers. Last but not least, you can bring your own data, basically uploading it to S3 and just using one of the self-serve tools, or you work with a consortium or an ESA to get the data there officially. Now, as mentioned, CDSE is big, and I mean, people probably don't realize how big it is. I realized that a week ago when I was reading a newsletter by USGS, and they were so proud that they reached the 200,000 terabytes of downloads of the Landsat product over the last 16 years. I mean, for CDSE, that happened like in a bit more than 2 years, we are off, right? So it's order of magnitude larger than Landsat, and we know how important Landsat is, right? So this is, and how used it is, and this is bigger, much bigger. I would argue that you can find the tools and the data that are like perfect for most of the AI processes, the feature engineering, model training, in analysis of the results. You can do all of this directly on the CDSE without additional tools there. Now, CDSE is free to use for everyone. I mean, there are some exceptions like Russia and Belarus and so on, but mostly it's everyone, similarly as Copernicus data. But obviously, because the budget is limited, there are quotas enforced on the individual level. Still, the quotas are large enough for someone to do a decent thing. Like, it's not just for trying out, you can really do stuff. The nice thing is that if you hit the limit, you are not kind of just blocked. You cannot go further. What you can do is you can use the commercial counterpart, which is called Creadius, which has the same services, same data. It's pay per use, right? And you can continue there. So again, most of the people use the free part, but if you need more, there is an option. The commercial part also does have credits for the researchers. Like you can just fill a form, say, I would like to have this much of storage or compute or whatever, and typically it's approved. So you should use it, and you get it for a few years or whatever. In terms of components, there is Copernicus browser, which is basically a WebGIS, which provides some analysis, not just visualization. There are tools to do the signal processing, like you can do feature engineering on the wall-to-wall, where you just split the area into smaller chunks that fit your ML process. Define the algorithm, how you would like to clean the data, cloud removal, gap filling, harmonization, everything. You define this, you have it running in a few hours, you can have the whole world processed. If you are working with the sparse areas, like polygons that are covering fields, you can do, as mentioned, the statistical analysis. Again, you submit a geo package with 50 million fields that were just generated in Open Earth Monitor project, and say I'd like to get time series of 2 years, and you'll have it in a few hours. You'll have it for in this case called or for work if you want. OpenGeoHub is strongly is very strongly used in the CDSE because we believe that OpenGeoHub is the most used standard for the processing of data, right? And we really put lots of weight into it as we want more and more people to use it, because more people use it, more useful it becomes. So much so that we recently developed the synchronous part of OpenGeoHub as well, which is now also powering Copernicus browser. So you can really do like either prototyping, fast prototyping, and large processing at the same place. There is a place to share the algorithms. This is super important if you want to actually build further rather than just create always the new stuff. And you can use this directly, immediately process the data. There's Jupyter Notebook, and you can even get a hosted compute with all the typical computing, GPUs, whatever is needed. Again, I think what is available, like off the shelf, is sufficient to start with the prototyping, analyze the data, do some small scale stuff, upscale it, and then even distribute it to other users on the same platform. Now, how can a project such as Open Earth Monitor or other research projects contribute to the whole this story of creating an impact? First of all, I would say let's reuse, not create new stuff, right? I mean, I'm sad to see that we have so many land cover maps globally, each one better than the other one, but very few used in some impactful work. I mean, we really, obviously some is better than others for these things and so on, and we just pick the one that fits us best and we go on rather than make it a bit better but new, because we will not add anything to the long-term success. When you do build the data, then put it to the CDSE so as many people can use it as possible. Tom mentioned that this is now being done with ARCO or with the Landsat bimonthly mosaics, which will be available through the same system, through the same services to anyone free of charge if they want. Put your workflows, contribute them to the common repository, because again, we need to reuse and build further rather than just create from scratch. Now, for institutions, I think this is also important part. Institutions such as, I don't know, European Union or environmental agency, they're very keen of ordering a design and development of a new data set, yet again, right? And they always start, I want you to build this thing, rather than using the things that are already there, because many of the things are already there and they're good enough. If there is a need to improve or build something new, rather than asking build new stuff, act as an anchor client, because this pushes the developers to create a product that is actually used by as many as possible, in the, let's say, environmental agency being one of these, rather than just building for specific purpose, and then after a few years when the project is gone, this is gone. And obviously ensure that the open data is really open. I mean, we heard a lot of discussion about Landsat. I also heard rumors about Sentinel data, should we keep it open and so on. I think this is like really important. We need to leave it open. And when creating policies, think whether they can be monitored with remote sensing data. We have EODR, we have carbon credits. All of these are very similar to common agriculture policy, and you can use the same patterns. But I mean, surprising, there is little mention of this at all. I'm part of this carbon removals and carbon farming. I mean, they don't even know that the AMS exists, unless, I mean, we told them so at that specific meetings. Again, showing the point that we don't use, but rather always start from scratch. So I'll stop here. If there's some questions,
we have some time for questions, and maybe I'll just start the most important actual stuff with Google Earth embeddings. So they went to CC BY, so you can also integrate them. And the second question is, many people asking, is this CDSE? Is it the European Google Earth engine? How would you answer that? So these two questions.
Good ones. So we actually do have some embeddings already on the system created by Cloudflare and IBM together, so not yet the Google ones. We are considering Google. The problem is a bit of a political, right? I mean, that Google is, as you know, that American thing, and we want to have as much European as possible. So the decision is not yet made, but I imagine it will be useful, and it's a relevant feedback. Compared to the Google Earth engine, it's not one for one, right? Google Earth engine to me is much more of a closed box. You go there to a specific tool, and I mean, it basically pushes you to do everything within that environment. You can then download the data out, but I mean, in reality, it's meant to be there. It's much less open. That's my view. CDSE is by design open. You have APIs for each and every part, and you can tap the APIs into your environment. So I don't know if OpenGeoHub has their own cloud infrastructure. You can use the CDSE from your own cloud infrastructure by integration with APIs. It's more difficult to do that with Google Earth Engine. I mean, you need to do the workarounds. Google Earth Engine has some features that the CDSE does not have. Very importantly, I think the gap is Google Earth Engine has a ton of existing processes that were contributed by scientists using Google Earth Engine, and you can just come and reuse. That's still missing at the CDSE, and this is the appeal to all of you to contribute, because then we can have more. But I mean, in reality, I would say that there's, for most of the things, most of the processes, you can do same thing with the CDSE as with Google.
Okay. Let's see questions from the audience. Johannes, please. You have more questions?
Thank you very much, and I would love to see more update of CDC across the science community. But one major difference I see, including also myself, is the free resources that Google, as a private sector company, provides to a broad range of users that has led to this update.
Okay, let's go because of time.
That's a good point, but as mentioned, you can get these kind of free resources at CDSE as well. I mean, for up to some level, you just put in your email. If you need more, there is a form to fill. And then it's either funded by CDSE or by the consortium, but most of the proposals that come in are accepted. So you can get, again, we don't have the unlimited budget as the Google has, right? But still, most of the requests are approved. So try it out.
Okay, we have two more questions.
Just comment any question. First of all, talking about the policy, Peter, I think that sounds like.
Because of the recording.
So, comment any question? For the policy reason, it'd be really nice to summarize and pick up a sentence that the CSP is really developing as the powerhouse of European data provision, and the more steps we make, maybe also the projects towards this point of the policy. That is an important technical side. Second question, what is this? Grega, is that you on the balloon, or what is it? It's Bennett's new ambitions, or
I mean, I don't have an answer to that. That was done by the designers. Might be.
The Americans shot the Chinese one like this. They shot it over there.
It does look like a modern paradigm. Yeah, I don't know.
Okay, Greg, also.
Thanks, one thing I was wondering also is whether we could really dream of having in CDSE also a much larger set of geodata, which I guess that the answer is yes, but I'm thinking of geostationary satellites. I'm thinking of things that are not there yet. I mean, it's not something that I as a user can easily just say, oh, I wish I had it. Sometimes Google has these. So in the Google Earth Engine, they have this catalog of many more things that actually stops me from going to CDSE for specific.
Okay, good. Let's see.
You should continue. And I think this is also should be part of the policy brief that we'll be making.
Yes.
It's an important point. I would answer for majority of the research that one will do, I would argue that the data are already there. I agree that some of them are not there. We are working to add more. Some require some political will because we still have the different institution, ECMWF and EN. This is not yet integrated as it should be. My suggestion would be, let's list as a project, let's list the 5 most important things that are missing, and ask for this to be put to the priority to be onboarded. I mean, we onboarded a lot of new stuff, so there is will and interest by both ESA and DEFIS and the consortium to do that. So yeah, let's make it a point that this is important, and let's list a few so that we put the project accountable to actually deliver this.
Okay, we'll have to stop. Thank you so much. Thank you for coming here.